Okay, in this video we want to continue looking at ellipses, and let me just start by noticing the difference between sort of a horizontal ellipse, like you see here, almost like a football that's lying on its side, like that, and where the major axis is horizontal, and the vertices and the foci and the center are all in line with this kind of horizontal axis. Okay, in that type of case here, and remember that A is the distance from the center to each vertex, and C is the distance from the center to each focus, and B is the distance from the center to each of the co-vertices. So A is bigger than B, and C squared is equal to A squared minus B squared. One of the important things to notice about this one is that since A is bigger than B, A squared is bigger than B squared, the A squared goes underneath the X part of the standard equation of an ellipse. All right, so if we switch it to sort of the vertical type of ellipse where the major axis is vertical, and you can see there's vertex, focus, center, focus, vertex, all in the major axis. The thing that does change, though, is since the x direction, or the minor axis in the x direction, is shorter than the major axis in the y direction, you switch the positions of b squared and a squared. They just switch. So now the a squared is underneath the y portion of the standard equation of an ellipse because it's bigger and this is longer in the vertical direction. So this is like a football that's on a tee being held up, or somebody's holding it upward. All right, so with that in mind, let's move to this type of problem. And in this problem here, we're asked to sketch the graph of the following ellipse. So forget about all this stuff below here. I'll get to that. And let me make this bigger. I'll move that up just a bit. There we go. So we have 25x squared plus 9y squared minus 200x plus 36y plus 211 equals 0. So it's an equation that's sort of a mess. It's not in the standard form. At this point, you may not, even know whether it's a vertical type of ellipse, a horizontal type of ellipse. How would you identify the center of it? What is A? What is B? What is C? What's H and K? And all that. To do that, what we're going to do is to use this completing the square technique again. And we looked at that a little bit with parabolas, but we're going to look at it here. So the first thing to do is to get the x squared term and the x term together. So I have 25x squared, and then I have minus 200x. So I'm just putting those together first on the left side. And then I'm going to get the y squared and the y term together. So plus, there's a plus in front of the 9y squared, so plus 9y squared plus 36y. And then I'm going to take this 211 and just subtract it from both sides to move it to the right-hand side of the equation. All right, so here's our x stuff, our y stuff, and then equals, and then the number. Don't worry that it's negative 211. Okay? Then focusing on the x stuff here, I have a number that's not 1 in front of the x squared. So I'm going to factor 25 out of both of these terms that have x's in them. So if I factor it out of the x squared term, what's left? I put parenthesis, and I have x squared, because if I took this 25 and distributed it back through, it would hit the 25x. The 25 would hit the x squared, and I'd get the 25x squared. And then I have my minus sign, minus sign. If I factor a 25 out of 200, I must have 8 left, because 25 times 8 would give me the 200. So now I have 25 parenthesis x squared minus 8x plus, I'm going to leave this blank for a second here. Okay? And then I'm going to move over to the y stuff. I have a 9 in front of the y squared, so I'm going to factor 9 out of both the 9y squared and out of the 36y. So I have a plus 9 parenthesis. That would leave a y squared inside the parenthesis plus a 4y. Because again, if I take this 9 outside the parenthesis and multiply it back through, I'd get 9y squared plus 36y. I'm going to leave this blank here. And obviously it's equal to 211. All right. Now, just like before when we completed the square, let's go into the x stuff here. And I'm going to look right at the number in front of the x, which is -8. And I'm going to take half of that. So -8 divided by 2, that's -4. And then I'm going to square that. And when I do, I end up with -4 squared, which is 16. And that's what I'm going to add to where this question mark is, this red question mark. So I'll put it down here. There's the 16. Go over to the y information. The number in front of y is 4. I'm going to take half of that. So 4 divided by 2, that's half of it. That's 2. 2 squared is 4. And that's what I'm going to put in place of this red question mark here. So there it is right down here. Now, these two numbers that I put in that are in red, they didn't exist before. So they're my creation. I'm not really adding 16 on the left side. I'm really adding, I don't know why it's doing that. Let me get rid of that. I'm not really adding 16. I'm adding 25 times 16. So if I'm really putting in 25 times 16, then I have to add 25 times 16 to the right side to keep the equation in balance. Likewise, right here, I'm not really adding this red 4. I mean, I am, but there's 9 out front of the parentheses, so I'm really adding 9 times 4, which is 36. Or I'll just go ahead and put plus a 9 times 4 on the right-hand side. All right, the beauty of completing this square is, let's go back and look at this x squared minus 8x plus 16. If I factor this trinomial, it would become x minus 4 times x minus 4, or an x minus 4 squared. I've completed the square. Okay, so now it's 25 times x minus 4 squared replaces this 25 times this trinomial. Over here, when I have the y squared plus 4y plus 4, when I factor that trinomial, it will be y plus 2 in parentheses times a y plus 2, or a y plus 2 in parentheses squared. So there's the 9 times y plus 2 in parentheses squared. I completed the square. It replaces all this. And now -211 plus 25 times 16, I think, is 400, plus 36. This entire right-hand side now becomes 225. And now you can see that I'm getting closer to the standard form equation of an ellipse. Now what I want to get is 1 on the right-hand side. So I have 225 here. I'm going to divide both sides by 225. I'll divide each term on the left by 225. I'll distribute that division. So I'd have 25 times x minus 4 in parentheses squared divided by 225 plus 9 times y plus 2 in parentheses squared divided by 225 equals 225 divided by 225. And when I do that, this is what I end up with. I now have it in standard form. X minus 4 in parentheses squared all over 9 plus y plus 2 in parentheses squared all over 25 equals 1. And there's several things that I can pick out from this. My h must be 4. My k must be -2. So now I can find the center. The biggest number underneath either of these is the 25. So that's a squared. So I'm using the vertical. If I go back to the vertical, this is a vertical ellipse. It should be one of these because the bigger number is on the a part, the a squared is underneath the y. So it's going to be like a football that's held vertically on a tee or somebody's finger. Okay? All right, so now I know that this is a squared, so a must be 5. This must be b squared, so b must be 3. And then I can use c squared equals a squared minus b squared and find that c is 4. This is important information for finding the focus. So now I know that the ellipse is vertical, and I've got all these cool things here. H is 4, K is -2, A is 5, B is 3, C is 4. I can go ahead and graph it. Okay, to graph it, I'm just going to use Desmos here. You don't need Desmos. You can graph it on, a piece of paper. It's no big deal. Let me make it bold. There we go. Nice and bold. All right, so what I've done here, or let me just do this. The first thing I would do is find the center. And what we said the center was, I think it was, give me a second. Oh, it was 4, -2. So I'm going to make my H4. You can see it's moving things around. And my K is -2. There you go. So just on graph paper, just go over 4 down 2. There's your center. Okay. And then from the center, I would move maybe to each vertex. So I found that A was 5, so let me adjust the A and make it 5 here. Okay, so from the center I'd go up 1, 2, 3, 4, 5. There's a vertex. The vertex, this one is at 4, 3. And then what else would I do? Let me move this. From the center I'd go down 5. So 1, 2, 3, 4, down 5. Okay, so I have both vertices, and then maybe I'll go ahead and use, let me adjust what, B was what? B was 3, so let me adjust that, and we'll find the covertices. There you go. So from the center now, I'll go to the right, 1, 2, 3. So there's a covertex. From the center, I'll go to the left, 1, 2, 3. There's another covertex. This one is 7, -2. This one is 1, -2. And so I could, plot those points there. And now I have enough information to go ahead and just draw my ellipse through the, kind of in an oval fashion, through the vertices, the main ones and the co-ones too. If I want the foci, my C is 4. So from the center, I would go up 1, 2, 3, 4 because it's a vertical one. So I have a focus at 4, 2. And then from the center, I go down 4. 1, 2, 3, 4. And so this focus would be at the point 4, -6. All right. All right, there's one other little concept that we want to look at here. I'm going to put it in its own video. It'll be a nice short one. You'll see what happens with it. It's called eccentricity. So let me move out of this video for a second and come back into another one.